So in this part we will continue with the tabulation method or the Quine-McClusky method, and this is the most general method which can be used to solve any problem. So till now we have seen that how to minimize any Boolean expression with the help of Boolean identities, and then we saw that how to use K-maps for the same purpose. Now we will use Quine-McClusky method to solve the problems, to simplify the expressions. And this method can be useful for any number of variables, and it is also useful for automatizing the process of simplification of any Boolean expression. So let's start. So this is, as I am telling you, that this method is also based on the identity which uses this particular identity x plus x bar is equal to 1. Okay, sorry, x plus x bar is equal to 1. So this is what the identity is. So this is the this identity is the main reason because of which we are able to solve the problems. This we can use this identity in different ways. Okay, so this is also, this identity is the basis for this Quine-McClusky method. So let's see. So what we do is in this particular tabulation method, you can see that we find the prime implicants and select the essential prime implicants or the prime implicants which are unavoidable to find the answer. So how to find this prime implicants and essential prime implicants? To find that we follow a simple procedure. So that procedure is something like this. So let's suppose a question is given to you. So whatever mean terms are given to you in the problem, so first of all list all the mean terms. Okay, so this is what the first step is. Then in the second step, what you do, you arrange all the mean terms in a column. Okay, right from the second step onwards, we have to arrange all the mean terms in the columns. Each column, like in the, let's suppose in the step 2. So what we will do is we will arrange all the mean terms in the increasing number of ones. Okay, so in the first we will choose those mean terms from the given mean terms. We will choose those mean terms which have least number of ones. Okay, so that will be our first index. So the number of the terms which have same number of ones is called particular index terms. Okay, so let's say you choose some terms in which 0 number of ones are present. So that is no one is present in the term. So those terms will be selected first and will come at the top. Then later on, those terms you will select which have 1 number of ones. So we will arrange the given terms, the given mean terms in the increasing order of ones, and either mean terms or the max terms. Suppose max terms are also given, so we will follow the same procedure. So there will be little change that I will tell you while explaining with the help of the example. We will understand that, but either the mean terms are given or the max terms are given, the procedure will be more or less same. Okay, so let's suppose I will talk about the mean terms. For the max terms I will consider later on. So what we will do, we arrange all the given mean terms in the increasing in the order of increasing number of ones. So this is what the first step we have to do. Now after arranging these mean terms in the increasing number of ones, we try to form the pairs. Okay, form the pairs, starting from the pairs. Here we don't start with the octet or the highest number of ones. We start with the lowest number of these groups. So let's start. We try to group the terms which have like only one change. Okay, so in the next step what we do is we group the terms which have only one change. Okay, and that one change, wherever that change is coming, will be marked with a dash, whereas the terms, the variables in which there is no changes. Okay, so if we choose two mean terms in which there are, let's say, 4 variables. Okay, each term is of 4 variables, then there will be change in only one variable. Okay, so a change at one place only. So those terms will be picked up which have only one change. So then those terms will be grouped. If there are more than one changes, then it will be then that group cannot be formed. So will not form that group. And again, as you see that in the step 3 also we do we are doing this thing particularly, and using this identity, which is your xy plus xy bar is equal to x. So y plus y bar is becoming equal to 1. Okay, because x has been taken common, so y plus y bar is equal to becoming is equal to 1. So this is what the basis of all the solutions. Okay, this is what, because of this identity we are able to solve. Now what we do is we keep on checking the first index with the second index. Okay, so let's suppose each term of the first index will be checked with the will check each of the index of the first index term with the second index term, okay, the succeeding index, and we'll see that how many changes are there, and we will form the pairs wherever there are like single changes. If there are multiple changes, then that will not be taken into consideration. And a single term can form multiple pairs, okay, can form the group with multiple terms. But once a particular term is able to form a group, we will put a tick mark across it. Okay, we'll put a tick mark across it, so that we know that this term is used in forming a group. Okay, if it is like used multiple times also, then no need to put multiple ticks, but one tick will work. Okay, so now every index will be checked for the next adjacent index. So this we keep on doing until all the indexes are not exhausted. Okay, then in the next step again we follow the same procedure. Whatever we have done to reach to the step 2 from step 1, again we follow the same step to reach to the step 3 from step 2, and step 4 to step 3. So in the next step, what we do in the third step, we have like formed the groups of the terms which we got from the first step, from the second step. Okay, so that is what we have done. In the fourth step, again we group the terms which we have formed, which we got in the step 3. Okay, following the same rule. So wherever there is single change, we choose those terms and we put a dash at the place where there is a single change. Okay, we keep on doing this. So this process will be more clear to you with the help of examples, but in general, if you want to know the process, then this is what the process we follows, and we keep on doing this until we exhaust all the possibilities of forming pairs or all the possibilities of forming any groups. So we keep on doing this till all the possibilities are not exhausted. Once all the possibilities are exhausted, then we mark the terms which are not yet used to form any groups. So those terms are called your prime implicants. Okay, so those terms which are not used to form any groups are called your prime implicants. Okay, so then from this prime implicants, whatever prime implicants we have got, we make a prime implicant table. So that prime implicant table will not consist all the terms, but will have only these terms which are not used to form any groups. Now these terms, this prime implicants now will be used to identify essential prime implicants. Okay, so what is this essential prime implicants? Essential prime implicants are the prime implicants which should come in the answer. Okay, without which the answer will be incomplete. Apart from that, there will be some maybe, in some questions there may be, in some questions there may not be this possibility. But apart from there may be some other terms which may not be essential prime implicants. These terms are called selective prime implicants. So selective prime implicants are those prime implicants which may or may not occur in the answer. So if you choose one selective prime implicant, then the answer will be complete. Somebody may choose some other selective prime implicant. Okay, so if there are multiple selective prime implicants, the question may have multiple answers. Each student or each whosoever is solving the problem may choose a different selective prime implicants, but the essential prime implicants will be same for all of you. Okay, whosoever solve the problem, the essential prime implicants will be same, but the selective prime implicants, which I have though not written in this particular slide, but there may be like selective prime implicants as well. So those selective prime implicants may or may not be there, but if they are there, then your answers may differ if there are multiple selective prime implicants. Okay, so this is what you do, and then later on, once the process is completed, we get the selective essential prime implicants and the selective prime implicants. Then depending upon the type of question, let's suppose the question is given in the mean term form, then the answer which we get is in the corresponding to each group, we get the mean terms, and then we add them up to get the expression in sum of products form. If the question would have been given in the max term form, then we add this terms, we multiply this each of the sum term to get the POS expression. So this is what the change is. Okay, so this is how you reach to the answer with the help of tabulation method. Now let's see how we use this method to solve the problems. So let's start with the example. We will consider the example for both for the mean term case and for the max term case, as well as with and without don't care. Okay, so let's say the first problem, we take the question which is expressed in the mean term form and which do not have any don't care conditions. Okay, so let's say we want to find the question is obtain the minimal expression for this particular which have 4 variables. You can identify, if this particular ABCD is also not written, then also you can identify that what can be the how many variables are involved by finding this maximum decimal number. So the number of variables should be less than 2 to the power let's say whatever this is coming, so this should be less than 2 to the power your number of variables. Okay, so this is how you find the number of variables. So here again, so the first step is, so these are the mean terms which are given in the question. So in the first step, what we do, we list the mean terms. So that step I have not written here, I have started from the second step onwards, but this is the list of the mean terms. Okay, so you can consider this particular question itself as the first step. So this is the list of your mean terms. Now to all these mean terms, what we have done in our very first step is we have arranged each of these mean term in the increasing order of ones. Okay, so you see this particular first mean term, each term will be expressed by 4 variables, then this particular mean term will be 0, 0, 0, 1. So this mean term will have only one number of, okay, one is coming in this mean term, so that will be our first term. Then are there other terms which have only one in that particular term? So let's say 2 if we consider, so the binary equivalent or the 8421 equivalent of this particular not 8421, I should say this binary equivalent. So the binary equivalent of this particular 2 will be 0010. Okay, so this 0010. So 0010 is again having only one. Okay, in this particular full term there is only single one, so that will be our second term in the list. Then let's say 3 if we consider, so the decimal equivalent of 3 will be 0011. So this term do not have single 1 in it, so this term cannot be the next term. So we'll find the term which have only single 1 in it. So the next term which have only single 1 in it is your 8. So 8, if you find the decimal equivalent of this 8, then it will be 1000. So 1000, as you can see that it is only having single 1 in it. So that will be our next term. So this is how we have listed. So this particular where I have placed this horizontal line. So this is our first index. Above this line it is first index. So first index is the index which have all the terms. It consists of all the terms which have single 1 in it. Okay, single 1 in them. So those terms. So the group of the terms in which there is only single 1. This is forming our index 1. Now we will move on to the next terms, which we'll try to find that is there any other term which have single 1. So we find that there is no other term which have single 1. So now we will move to the terms which have 2 number of 1s in them. Okay, so let's say 3 is the term which have 2 number of 1s in it. So 0011. So this is the first term in the second index. Okay, now let's say the other term. So 5, okay, then 6, then 9, then 12. So these are the terms which have two ones in them. So we have listed them in the increasing order of ones, okay, increasing this decimal numbers. Now this again I have placed this this horizontal line to demarcate the index 2 from the index 3. Okay, so this is our index 2 terms. Okay, then let's move on to the other terms. So this is the list of terms which have 3 ones in them. So this is our index 3. Then the next index, which is our index, okay, so this is I have written like probably, so you ignore this one, the last one. Okay, so this is the last 15th term is the particular term which have maximum number of ones in it. So all ones are in this term. So this is our the highest term. So this is the line, this horizontal line is separating the index, third index from the fourth index. So this is the fourth index. So this is how we have listed it. So ignore this particular term. This is multiple times I have written, so ignore this last row. Okay, now let's say we have listed this term in the increasing order of 1. So this is our first step. Now in the second step, what we will do, we will try to group the terms with from one index to the next index. So let's say we pick the any first term from the index 1 and we'll try to group it with the terms of the second index. So now the grouping is possible only if out of the 4 variables, each term have 4 variables. So out of the 4 variables, 3 variables should the bit locations of the 3 variables should be same. Okay, whereas there can be change in the one of the variable. So, but the change should only be in one of the variable. If there are if the multiple variables are changing simultaneously, those terms cannot be used to form a group. Okay, so here we can see that term number 1 if we pick, and from the second index if we pick term number 3, then we can see that there is a change in variable C. Okay, whereas A, B, D, A, B and D variables are same. A is 0 here, B is 0 here, D is 1 here. If you see the term third here, so A is 0, B is 0 and D is also 0. Okay, whereas C is 0 in the first term, whereas it is in this particular term it is 1. So there is one change. Okay, so this is how we identify that there is one change in this particular term. So now these two terms will be listed together. So these two terms will be used to form a pair. Now as this both the terms are used to form a pair, we put a tick mark here. So a tick mark at both the places. So this both the terms are used to form a pair. Okay, now you see how we list this particular term. So and we write it here. So 1 3 is this particular row is coming for the term which is 1 3. So 1 3. Now how we list it? So you see the variables which are not changing, so we'll write them there, and the variable which is changing, so we put a dash mark in front of that. Okay, so for that variable which is changing, we put a dash mark. So as variable C is changing in this both the terms 1 and 3, so we mark dash in location C, whereas the other locations which are unchanged, we put them as it is, so 0 0 and 1, right? Now we try to form this particular with some other. Is it possible to form the groups? This particular term is useful to form group with other terms or not? So we'll check it. So we see that this particular term is also useful in forming the group with this term 5. So we'll form the group with this term 5. So again we will see that the variable B is changing in this case. Okay, so we have marked a dash here, right, following the same procedure. Then we will check the same term with the next term 6. So we see that there are two changes. So you see B is changing, C is also changing, and D is also changing. So there are 3 changes in fact. So this particular 1 6 cannot be a pair. Okay, because there are multiple changes, right? So that is why we have not formed a 1 6 pair here. Now let's see, check the one with the other one 9. So 1 with 9, again we can see there is only one change in location A. Okay, so this is marked here and we have written the other terms and also tick marked them. Okay, so you see now 1 with 12. So 1 with 12 there are 3 changes. Okay, so that is not used to form a pair. Okay, now let's do the same thing with the next term. So we try to form this with all other. Okay, so we take the second term from the index 1 and try to compare them and try to form the pair of this second term of the first index with all the terms of the second index. Okay, so we'll check this term particularly with each of this term one by one. Okay, so we'll see 2 3, so 2 3, so 2 with 3. So you see there is only one change in bit location D, so we form a group here. So D is marked dash, whereas other terms which are not changing are written as it is, and 2 and 3 are 2 is 3 was already 3 we have already marked tick here in the previous case, so we will put a tick mark here for this second term. Now 2 with 5, so 2 with 5 cannot form a pair. 2 with 6, okay, that can form a pair, so 2 and 6 will form a pair. Then 2 with other terms, 9, not possible. 2 with 10, 12, sorry, not possible. Then let's try with 8. Okay, so 8 with other terms. So 8 with 3, not possible. 8 with 5, not possible. 8 with 9, 8 with 6. So you see this one by one and keep on doing this. So we see that 8 and 9 can form a pair. So 8 and 9 are used to form a pair, and again the dash mark is placed here. So we keep on doing this for the adjacent indexes only, because if you try to form the pair with this index with the not with the adjacent index but with the next index, so then you will see there will always be multiple changes. Okay, there will not be the possibility of single change. So that is why we don't compare with this index with the first index with the third index. Okay, the reason is this. That is why we compare only the first index with the second index, the second index with the third index, and the third index with the fourth index. Okay, the adjacent index are only compared, not the otherwise. So we list all these terms and we put a dash mark wherever there is single change. So this was about our second step. So this is how we have done our step number 2. Okay, now this particular step is, this particular process, whatever we have done here, we follow the same procedure for this column. Okay, so for this column again we will follow the same procedure. So what we will do again, now in this case, to form the group, the dash should come at the same place. Okay, so this you should keep in mind. So you see, we'll take this particular term, let's say 1 3 first, and we'll try to form. Now we will see the first we'll try to index them. So this horizontal line, I'm talking about where to put this horizontal line. So to put this horizontal line, we will see the number of dashes. Okay, the number of ones. So these are the particular terms which have only single ones. So the terms which have single ones are like separated from the terms which have other higher number of ones. So this particular group have more than one number of ones. So we have separated this group from this group. So this separation is our index 1 for the second step, and this is index 2. So you can see that similarly we have separated the terms which have 3 number of ones from the terms which have 2 number of ones. So this is our index 2 and this is our index 3 for second step. Okay, now again we will do the same procedure and compare the terms of index 1 with index 2, or the adjacent indexes, the terms of adjacent indexes. So we compare this term 1 3 with the 3 7, let's say. Okay, so 3 7, so the terms are common here, so they will not be compared. Okay, so you will see that there will be multiple changes, and the dash is not also coming at the same place, so they cannot form the term. Okay, now 1 3 with 5 7. So 1 3 with 5 7, you can see that the dash is coming at the same position. So the dash in the 1 3 term is at the variable C. Similarly, for the term 5 7, the dash is again at the same C position. So if this is the case, then we try to compare. Then we see that whether are there, after this dash, whether there are single changes or multiple changes. So after this dash, there should be single change. So you see 5 and this particular term and this term, A variable is 0 in both of them. So okay, fine. B is 0 in this term, whereas it is 1 in the 5 7 term. Whereas C is dash in both the terms. D the variable t is 1 in both this term 1 3 and 5 7. So you see after dash also you can see there is only one change in these two terms. So if there is only one change, then they will be used to form a next group, next higher group, or you can say a quad. So a quad is formed with 1 3 5 7, and now you see that the b variable is also changing. So we put a dash mark also in the location at this b variable. Okay, so this position also. So there are two dashes are coming in this particular case. Okay, and the variables which remain same, we have written them as it is 0 and 1. Now for the next, we'll do the same thing for the next higher group. So 1 5 we check it for the 1 3 we check it. First we check this particular with all the terms of the second index. So we find that it is not possible to form any separate group. So if this 1 3 5 7 is formed, again you may find that here in this case you are not able to form any other group. So this particular group will not be used to form any other group. Okay, now let's see. We'll try to form this 1 5. We'll check this 1 5 with all the terms of this index. So 1 5 3 7 dash is at the same position 1 5 and 3 7, but we have already 1 3 5 7. So we have already formed them. We have already used this particular group. So if it is 1 3 5 7 or 1 5 3 7, it doesn't make any difference. So it will be considered as the same group. Okay, 1 3 5 7 1 5 3 7. Okay, if it is coming in the different order, then also you will see that the bit positions, the changes will be at the same positions. So then they will be, that particular group is also considered as the same, and it will not be if order is different, then we don't write it multiple times. Okay, keep this in mind. Then we check it and we see that 1 5 is able to form the group with term 9 13. So you see 1 5 is able to form, we have formed the group with that. Okay, and again we have marked the dashes in the positions wherever there are changes. Similarly, we check particularly this index with all the terms of this index, taking each of this, picking each term, and then checking all the terms of this particular term with all the terms of the second index, then second terms of the first index with all the terms of the second index, and so on and so forth. Okay, and then we pick the second term, okay, first term from the second index, and check it with all the terms of the third index. So keep after doing all these things, we find this particular all the terms. So now we will try to form the group. Again we will try to do the same thing if it is possible to. If it is not, then we will stop. So again we see that we are able to form this particular, let's see. Okay, let me see. So in the next step, in this particular step also, after getting this all the quads, we try to form these, we'll try to do the same thing. Okay, if it is possible to form the groups, then we will write the terms here. Okay, and if it is not possible, then we will write the prime implicance table. So we see that this is our, again we separate the terms which have one number of ones in them with the terms which have two number of ones, and so on and so forth. So we can see that there are only possibilities of forming two groups. So first group which have only one number of ones in it, and the second group which is the second index which have two number of ones in it. So these are the two indexes. So this is the index 1 for step, this next step for this column. This is index 1 and this is index 2. So we'll try to again do the same thing. So we'll take this term and we'll try to compare with this term. But we can see that as the dashes are not at the same place, because from this index if you pick any term and if you pick the one term which is the only one term which is available in this second index, so we see that there are no term in this first index which have the same the dashes at the same place. Okay, which this particular term is having. So that means neither of this term can be used to form group with this term. So we see that any of this term cannot be used to form a group with the next higher index. So then these terms cannot be used, will not form any group. Okay, so if these terms are not forming any group, then they will be returned here. Okay, so this terms, whichever all the terms you can see, except this terms, this one first term, second term, third term, fourth term and fifth term of this particular step, okay, except this 5 terms, all other terms are used to form group with some other term. So this 5 terms which have not been used to form any the group with any other term will be called your prime implicants. So taking this term, we form a prime implicant table. So on the here we write all these terms, okay, all these mean terms which have not the groups of all these mean terms which have not which are not able to form group with any other group. So you see, these are all the groups. Now here what we will do, we will write those terms. Okay, this ABCD is nothing but the binary equivalent of this particular group. So corresponding to 1, 3, 5, 7, whatever we are getting here, ABCD we have written. So 0 dash dash 1. Okay, so this you can see 0 dash dash 1. Corresponding to this, say 5, 7, 13, 15, you see dash 1 dash 1. So 5, 7, 13, 15 dash 1 dash 1. Okay, so this is how we have done it. Similarly for the other term if it is there. Okay, so once we have done this, now what we should write here. So the question is what we should, so here we got in this column what we should write, in this row what we should write. So to find this, what we do is we just write all these terms which are given in the question. So 1, 2, 3, 5, 6, 7, 8, 9, 12, 13, 15 are given in the question. So we repeat them here as well. Okay, so the same terms which are given, which are given in the question, the mean terms which are present are written here. Okay, so this is what it is written here. Okay, every term. So without any exception, we will write all these terms here. Now once these terms are written here and this terms which are not used to form any groups, these are written, this table is called your prime implicant table. Okay, now this prime implicant table, from this prime implicant table we will find the essential prime implicants. Okay, so you see what we do. So we do is, see, corresponding to each of them, see this 1, 3, 5, 7. So whichever mean term is coming in this particular group, we mark a circle against it or a cross against it. So we see we have marked a circle here. So this 1, 3, 5 and 7, this particular mean terms are coming in this group, right? Similarly 1, 5, 9, 13. So whichever terms are coming here, we'll mark the circle in this term, in this particular place. So this is 1, then 5, then 9 and then 13. Okay, so similarly we'll do it for the other this rows as well. So 2, 3, 6, 7. So 2, 3, 6 and 7, right? Then 5, 7, 13, 15. 5, 7, 13, 15. 8, 9, 12, 13. 8, 9, 12, 13, right? Now you see, we try to find that the columns, okay, in which there is only one dot. So you see that particularly first column there are 2 dots. Okay, so just don't do anything with that, let it be like that. So first identify the columns in which there is only single dot. So you see this column is the column in which there is single dot, then this column is the column in which there is a single dot, then this column is the column number 8 is the column in which there is a single dot column, then single dot column. So we have identified these columns which have only single this. Okay, so the mean terms, the group which is coming corresponding to this will be our essential prime implicants, right? So you see this should come there. So 2, 3, 6, 7. So if you pick this particular, so then 2 and 6, okay, they are coming here. So along with that 3 and 7 will also come, but this particular term will come in the answer. So corresponding to this, if we find the term, then we'll find some term. So you see, we'll come to this particular how we'll get this, but this will be our essential prime implicants. Okay, so how to find the essential prime implicant? We first see the columns in which there is only single dot is coming, and corresponding to those dots we see the terms which are coming. So corresponding to these 2 dots we are getting this term, and corresponding to this particular dot we are getting this term. So if there is only corresponding to this particular dot we are getting this whole term, so no problem. So now corresponding to these 2 terms we are getting this term. So in the answer, this particular term 2, 3, 6, 7, 5, 7, 13, 15 and this particular 3 terms will be our essential prime implicants. Okay, so this is how we find our essential prime implicants. Now after doing this, we are still left with the sum terms, but we will see that whether these terms will form, should come in the answer or not. Should they be called as the selective prime implicants or not? So that we'll consider later on. But first we'll see that how to get these terms. Okay, so you see, to get this, or rather we'll see it later. First we'll consider that after doing this. See, after this finding out that the columns in which there is single terms, we see that we try to find, or we have to find that still after doing this, which columns are still not having any contribution in the answer. Okay, so after picking this particular term, this particular, and this three terms, we can see that 2 is coming in the answer, 2, 3, 6, 7. Okay, then 5 is also coming, 13, 15 are also coming, 8 and 9 are also coming. So right from the 2, 3, 5, 6, 7, okay, 8, 9, then 12, 13, 15. So these all are coming. But if we, if we are picking all these three groups, still we are not giving, we are not getting any contribution from this particular two terms. So then you see this right from not this two terms, this first term only. Okay, so we are not getting any contribution for this from this term. So in the answer, this term is not been represented yet. Okay, 1, because you see any of the group you pick, 1 is not there. Okay, so you should have in the answer the contribution from each of this term. So if you pick these three terms, at least there will be one contribution, at least there will be contribution from each of this mean term. Okay, so 2 will be contributed once, 3 is contributed like once, 6 once, 7 is like twice. So no problem. More than one is if the term is coming more than once, then it is not a problem, but it should come at least one. So you can see that after selecting, even after selecting these three terms, okay, these three groups, we are not getting any contribution from this one. So we have to pick some term out of these two terms which is able to contribute corresponding to this term. Okay, so you see, if we pick either this or this, we will have this contribution from this one term. So this one will also come in the answer, should come in the answer, and by picking any of them this one will come. So these two terms will be called your selective prime implicants. Okay, so this question particularly have the problem of selective prime implicants. So now somebody may pick this term, or some of you may pick this term. If you pick this term, no problem. If you pick this term, still there is no problem. But if you pick both of the terms, then your answer will be wrong. Okay, so from the selective prime implicants, you have to pick only one of the selective prime implicants. Okay, selective prime implicants corresponding to this particular term. Okay, so this particular for term 1, for corresponding to term this mean term 1, we have two selective prime implicants. So we have to pick only one of the selective prime implicates for this mean term. Okay, not for the not otherwise. Now, and you see in the answer we have to pick all the essential prime implicants will be there, but one of the selective prime implicants will come for this mean term 1. Okay, so you see, I hope my point is clear to you. Now after covering this, that which terms will come in our answer, so particularly you will have two answers for this question. Okay, so I'll show you both the answers, but we'll first see that how to get this particular term corresponding to the this any given term. So you see, first we'll talk about the essential prime implicant. So let your group is 2, 3, 6, 7. So this is your quad. So corresponding to this, you want some mean term. Okay, some term, not the mean term. You want some simplified term. So how to get that simplified term? So to get that simplified term, you just check this. That is why I have written this. Okay, this whatever we have got from that previous table. So if that is why you have written it. So you see, the variable for which we have written 0 in the column, that variable will be written as complement. Okay, so this you see, in variable for this variable a, there is a 0 in this column, so we have chosen a dash. Okay, and as in the question the mean terms were given, so we have written the term in the product form. Okay, so this is what the reason. If in the question the terms were given in the max term form or the max term forms, then we would have written the question in this complement of this particular thing. Okay, or the terms in the sum form. In that case, we should write the terms in the sum form. So we have written this, and for this variable c, you can see that 1 is written in the column, so that is why C is coming. So that is why A dash C is coming. Similarly, you can see for this particular term, if you want to write the simplified form, then you see that for this column B is 1 and D is also 1. So corresponding to this, which term should come corresponding to this? So it should be B and D. Okay, let's say I choose some other term, so let's say this term. So for this term, if I want the simplified form, then it will be A then C bar. Okay, so wherever these terms are coming, if 1 is coming, then we'll keep the variable. If corresponding to a variable there is 0 is filled in the at that particular place, we'll choose its complement. So that is why we've written, okay, C dash, right? And for this, similarly you can write the things for this two particular columns, this particular rows as well. So we have we found that how to get these terms. Now once we have found this, then we already have discussed this. These are our essential prime implicants, and after doing this, our selective prime implicants are these two, and we will choose one of them. Okay, so our answer will consider C. Now our answer, if we want to write, so our answer in the, now once we got this particular all the prime implicants and the simplified form for each of this group, okay, corresponding to each of this group, then what we do is we now write the answer in the minimal form. To write the answer this mean terms, this essential prime implicants should be there. So we have chosen each of these essential prime implicants. So A dash C, you can see, is coming in the answer. A C dash is also coming in the answer. A C dash. BD is also coming. So BD is written here. So that is coming. So they are these three are the essential prime implicants. So they are coming in the answer. Okay. So but you see, we have not taken all both these selective prime implicants. Okay. So we have taken only one of the selective prime implicant in the answer. So your answer can be this or can be this. If you have written this, then also it is correct. If you have solved this, then also if you get particularly this type of question and you get to this answer, then also it will be considered correct. And if you get to this answer, then also it will be correct. And if you write then like both, I have written I have written both the things, both the answers, so then also it is right. But if in a single statement, okay, you write all the terms, then your answer will be considered wrong. Okay, so rather if you suppose you write this and you also write in this particular answer, you include this C complement D also. So your answer is this term, this and plus C complement D. Okay, or this plus A complement D. Then your answer will be considered wrong, completely wrong. Okay, because you don't know the importance of essential prime implicants in the selective prime implicants. So this is what is meant by essential and selective prime implicants, and this is how you choose them to write the answer. So I hope the method is very clear to you. So in few words I'll summarize whatever we have done so far, and then we will move on to the next question. So first of all, we whichever terms are given, we arrange them in the increasing order of ones in the first column, then we index them depending upon how many numbers of 1 are present. Okay, so our first index will be the index which have 1 number of ones. 0 index will be the index which have 0 number of ones. In the previous question there was not any 0 index, but there can be also 0 index. Okay, so we arrange them in the increasing order of ones in the first column, then we match each term from the lower index to the higher index, each of the term from the higher index, and then see how many changes are there. If we find the terms which have only single change, then we use them to form the next higher group and we write in the next higher column. Then after exhausting all the terms from the first column, we move on to the second column and do the same process. Now wherever there was a change, we have marked a dash there. Now again for the second column we follow the same procedure which we have done for the for the first column, and we again mark the indexes. Then we group the first index with the lower index with the higher index, first index with the second index, and then finding the locating the dashes should be at the same position. If the dashes are coming at the same position, after that there should be only one change. If you find that, then we form the group. If we don't find that, then we don't form the group. Then we do whatever groups we have formed, we write them in the next column, and we keep on doing this until and unless we are not exhausted with all the terms and we don't have any no more groups are not, there is not any other possibility to form any groups. Now whichever terms have been used, we put the tick marks. We have already discussed this, so we put a tick mark corresponding to those terms which have been used to form groups. Now the terms which have not been used to form any group will be called your prime implicants. Then those prime implicants will be used to form a table which is called the prime implicant table. In the prime implicant table, we write all the groups which have not been used to form any further groups, and on the top we write all the terms which are given in the question. Then we mark the terms corresponding to each of this group, and then we put the circles against them. Okay, then we see that which column have single circle. So those single circle columns are your corresponding to those single circle columns, the terms which you are getting are your essential prime implicants. So okay, that's essential prime implicants should come, and then we go for the selective prime implicants. Okay, so then selective prime implicants are also chosen. Then essential prime implicants should always come in the answer, but selective prime implicants, one of the selective prime implicants should come corresponding to a term in the answer. So this is what in short we have discussed so far. Okay, so I have summarized that everything. Now let's move on to the question in the mean term expression form, but with don't care. So if you have been given with a question, if you come across a question which has been given in the mean term form, and also it has some don't care conditions, okay, and you have to solve this question with the help of tabulation method. So how to do it? Again, the procedure is simple, but there is only a slight change, so I'll explain that to you. So what we do is, in the first step, without considering them as the don't care, we arrange them in the first column, okay, in the increasing order of 1. So you see, although 1 is the don't care here and it is not given as the essential term, we write it here when we see that how many number of ones, this binary equivalent of this, each of this term will have how many number of ones are present. So we see that 1 is also the first, 1 is the term, 1 is the mean term which have single number of 1 in it. So we write 1 as here. So without considering, in the very first step, without considering them as the don't care, we write all the terms which are given in this question, okay, here, and arrange them as we have done in the last question in the increasing order of ones. Okay, so you see, this is our first index which have single number of ones in them. Then this is our second index, the terms which have two number of ones in it, okay, so in them. So then we've chosen the terms which have three number of ones in it. So this is our third index, then the higher index. Okay, so there are 4 indexes, 1 2 3 4. Now we group them. We try to form the groups for the terms which have only single bit change. So this one, if we try to group with this term 3, then we see there is change in this C variable. So you see 1 3 is forming a group, then 1 9 is also forming a group, but 1 10 is not forming a group, so we have not taken it. So following the same procedure, we exhaust all the terms, and whichever term is used to form the group, we put a tick mark across. So this tick marks shows that all the terms are used to form the groups, and we get the second column. Right now we see that, again we separate the terms which have single number of ones from the terms which have two number of ones. So we see that this particular terms have single number of ones. So this is our index 1 for the next step, and this is the index 2 which have 2 number of ones, then the higher index which have 3 number of ones. Okay, now again we do this particularly pick this term, and we'll try to form the group with this term, but we see that the dash is not at the same position, so this cannot be form a group. 1 3 3 11, again the dash is not at the same position, so no possibility. But 1 3 9 11, so let's see, and we see that it can be used to form a group. Okay, so it will form a group 1 3 9 11. Why? Because the dash is at the first thing is the dash is at the same position. C is at this particular location C. In this particular term there is a dash, and in this 9 11 also the dash is coming at the same position. Okay, so dash is at the same position, so this is the first condition. The second condition is that there should be one change. So you see in the variable v, this variable v is 0 here, whereas variable b is 0 again here in this position, whereas you see this variable a is 0 here, whereas variable A is 1 here. So there is one change, okay. Other things, other variable, D variable is same in both the terms. So you see, we have formed a group, okay. Similarly, now where was the change? So there was a change in variable at A location, so we have marked dash there, okay. So similarly, we do it for the other terms, and we see, and whichever terms are used to form a group, we put a tick mark, okay. So we have all the terms have been used to form the group, and then we get this next column. Now we check it for, again we separate the terms which have single number of ones with the terms which have more than one, okay. So two number of ones. So we find two groups, and then we try to again form the groups, this particularly picking this term with picking this term and trying to form the group with both of them. So we see that it is not possible to form any group with this term with this any of this term, because the dashes are not at the same position. Then we see that this particular, all these four terms are our prime implicants, okay. So we choose all these terms and form a this prime implicant table. So all those terms are taken there, taken from here, this, and corresponding to this the binary equivalents are also taken and written here, right. Now what we do is, now there is a change in case of don't care, okay. So you see, first we write this here, we write in this in the vertical column, this write all these things. So in this particular column we have written all these terms from this column which are not used to form any group. Now after this, what we do is, here the question come that what we should write in this particular row. So for this, see, there is this particular change only, okay. There is the change is there in this particular place only in this question. So you see, what we have done in the last question is we have chosen the terms which are given in this particular, okay, this here after the summation, all the mean terms which are present. But in this question the don't cares are also present. So in the while writing the prime implicant table, okay, we don't use this terms, we don't take this don't care terms, okay. We here in this row, okay, which terms we should write? We should write only the terms which are present here, not the don't care terms, okay. So that is what the only change. Now you see, we have written 2, 3, 7, 9, 11, 13, and you see that 2, 3, 7, 9, 11, 13 are only present. 1, 10, 15 will not write here in forming the prime implicant, the prime implicant table, okay, or the prime implicant chart. Then after doing this, again the procedure will be same, okay. So you see, now there is no change, so it will continue with the same procedure which we have done in the last problem. So you see, corresponding to this, each of this term will mark a 1, okay. So you see 1, although you can see here, but it was given as a don't care, so we don't have any column corresponding to it, so no need to worry about it, okay. So whatever terms are coming in this, and if they are not the don't care, then mark them up. So you see 9 and 11, so 9 and 11 are marked. 3 is also been marked here, so 3 is also, either you put a cross or you put a circle, okay. So whatever is your choice. So you see, we have done this. Now 2, 3, 10, 15. So 2, 3, 10 is not here, so no need to worry. 15 is also not here, so no need to worry. So then corresponding to this 2, 3 and 11. So we have written them. Then 3, 7, 11, 15. So 3, 7, 11 and 15 we have left. So 9, 11, 13, 15. So corresponding to them we have placed cross marks. Now we will see the columns in which there is only single cross mark. So we can see that this column number 2 is the term which have single cross mark, okay. So corresponding to this, the whatever term will come will be our essential prime implicant. So this star mark shows that this is our essential prime implicant, okay. Now let's see this one. So this term, okay, there is only single column in this, and corresponding to this you can see this term is coming. So this is also our essential prime implicant, okay. Now corresponding to this 13, there is only single cross in this column. So we put a 13 here as well, okay. So 13 corresponding to this. So you see, this 3 terms, this and this, these are called our essential prime implicants, okay. So the star terms are our essential prime implicants. Now we have to choose that whether this term should come in the answer or not. So we will see that whether the contribution from this 3, 9, 11 has already been included after taking this term, or are they left out. So you see, if we see 3, so 3 is coming, so okay, no problem. 9 is also coming. 11, so 11 is also coming. So you see, whatever essential terms, whatever mean terms given in the problem, okay, are coming in this particular group are also coming in this group. So if you choose this group, then there will be repetition for this 3, 9, 11. So thereby, that is why we don't need to choose this group. Okay, if you don't even choose this group, then also there will be contribution from 3, 9 and 11. And 1, as it is a don't care, then it can be treated as 0 or it can be treated as 1. So 1, there should not be, it is not necessary to have any contribution from the don't care terms. So 1 being a don't care, we don't need contribution from that in our answer term. Okay, in our answer. So you see, this particular term is non-essential prime implicant and it is a non-selective prime implicant term. Okay, so we don't have to choose this group. So our answer will now, in this case, will have only these 3 terms, okay, corresponding to this. And the terms corresponding to this, although I have forgot to return them here, but if you find them, you can easily find from this binary equivalent of these terms. So this binary equivalent ABCD, we have copied it from here. Okay, so this is nothing but the same thing which was written there. So you see, now you see, corresponding to this, if I have to write, then what will come here? It will be, see, B, at B location, at B variable location, we are getting 0. So it will be B bar. Okay, corresponding to C, it will be C. So the term corresponding to this term, this group, will be B bar C. Okay, so the C, the B bar C. Now corresponding to the next group, we have C and D both in the both uncomplemented form. Okay, so the term will be CD. Similarly, for this group, if you find, then the term will be AD. Okay, so this is how you get the answer, and this is what your answer is. So in this case, there will not be multiple answers, there will be single answer, and this is what the answer is, right? So you see, this is how you use this tabulation method to simplify the question. Okay, now let's try to understand the same method with the expression given in the max term form. So in the max term form, I have already told you that what to do. Okay, but in the max term form, if you want to revise it, then in the max term form, the answer, we'll do everything. Let's suppose the terms are given in the mean term. Okay, so we'll just consider that the terms given in the mean term form and follow the same procedure what you have done in the previous question, even if the terms, even if the question is given in the max term form. Okay, so write them, follow the same things, but in the last step only there will be some change. So the change will be there, two things. If don't cares are there, then whatever we have done in the last question will follow that only. In the prime implicant table, we will not include don't care terms. Okay, otherwise in the first step, right from the first step to the steps before the prime implicant table, we will consider the don't care terms as the given terms only. Okay, as the terms present in the question. But in the prime implicant table, prime implicant table, forming the prime implicant table, we will not use them. Okay, one change. Then the other thing is, while writing the answer, we will write the terms in the max term form. Okay, not in the mean term form. We will not write the product terms now. We will write the sum terms. And the simple way to write it is, like, suppose you consider them as the mean terms and write the corresponding mean term. And okay, so corresponding to that mean term, if you want the corresponding max term, then you just take the complement of it. Okay, or apply the De Morgan's on that term, that mean term. So you will get the corresponding max term. Now the final answer will be product of sums rather than the sum of products. So that is what the simple changes which you have to do if your question is given in the max term form. So let's try to understand this with the help of an example. So now let's see, this question particularly is given in the max term form. So these are the max term which are present, and this are the don't care for it. So I have considered only one question for this and including the don't care. Okay, so you see, what we do is, again we follow the same thing. Now here in this question, we don't know how many variables are used. So you see the number of 14, and being the highest number present in all the mean terms given or all the max terms given. So corresponding to this, if you find 2 to the power x is equal to, should be greater than equal to 14. So if you find this, then 4 will be this x will be equal to 4. Okay, so now the question will be of 4 variables. Now again you arrange them in the this na index 1, index 2, index 3, so increasing number of ones. Although I have not written them in detail, but if you find them, you can see that the terms which will come here will be 2, 8, okay, 2 and 8 will come here in the first index. Then in the second index, 3, 10 and 12 will come. In the third index, 13 and 14 will come, okay. Then corresponding to this, you can see that this 2 and 3 will be used to form a group. So 2, 3 is written there. Then you will see that 2 and 10 are used to form a group. So I am telling it in short. You try to solve the problem by your own, and if you have any doubt, you can talk to me. Okay. The detail for this you will find in the book as well. Okay. So this is, I have taken all the problems from the book. Okay, from your book Anand Kumar, and these are the example problems. So you will be able to easily understand. Okay, it's not difficult. So you see, then this 2, 10 is 2 and 10 are grouped together to form a group. Okay. Then similarly you can see 8 and 10. Okay, 8 and 10. And this 1 you can see whatever it is the location. Okay, 842 location if you write. Okay, so binary equivalent. So then this is the location where the dash is coming, right? So this is what it is. So in the bracket whatever you can see is the location where the dash is coming. So we write it like this. Then again we form the group. Then whichever terms are used to form the group with some other. So 2 is used to form the group with 3. So we put a tick mark on both the terms. Then 2 is used to form the group with 10. So we put a tick mark on this term as well. Okay. So then 8 is used to form the group with 10. So 8 is also. So similarly this way you put the tick mark as well. Then after doing this, we get all the pairs. Then from this pairs, again we do for this pairs, again we do the same thing, and we find that we get a quad corresponding to it. Okay, so this is the quad which we get. So now once we get the quad, okay, this terms particularly, this 2, 3, 2, 10 and 12, 13 are not used to form any group. So this particular are used to form this group. Okay, so this 2, 3, 2, 10, 12, 13 and this particular are your essential prime implicants. So taking this term will form a essential prime implicant chart. Okay, sorry, not the essential prime implicant, prime implicant chart. So these are the 4 terms which are coming here. These are this table, prime implicant table we are forming. So this terms we have written there, and now you see this question, in this question don't cares were also given. So when we write the prime implicant table, we don't use don't cares here. Okay, so ignoring the don't care, we write the terms which were given there. So then we write them here, and again we do the same thing, mark the corresponding to these terms, we mark the cross corresponding to them. So you see 8, 10, 12, 14, so 8 and 12, okay, are present there. So we have marked a cross there. Now after doing this, again we do the same thing, whichever terms are present, then we see the columns which have single cross. So this column is having single cross, so corresponding to this if I see, so this term should come. So this is our essential prime implicant. Corresponding to this term will come. So this is our essential prime implicant. Then this column is also having single one. So this is our essential prime implicant. Okay. Now after doing this, finding the essential prime implicants, we will see that whether all the these terms are being included in this when after taking these 3 terms, or like we have to choose this term as well. Okay, in the answer or not. We have to find that. So you see 2, if we start from 2, so 2 has been included in this. So 2 is multiple times it is coming, so no problem. So 2 is, if we take this term, so 2 is included. 3 is also included. Then if we take this term, 8 is also included. 12 is also included. 13 is also included by including which term? This term. So which term I was telling? This term. So 13. Yes, so 13 is also included by taking this. So you see this and this. So no need to take this, because 10 is actually a don't care, and that is not required, and 2 is already being used by using this term. So no need to take this particular. So this is not your non-essential prime implicant. Okay. So apart from this term, all these groups, apart from this group, the other groups are your essential prime implicants. So they should be included in the answer. But now the question is how to get the corresponding max term corresponding to each of these groups. So to get the max term corresponding to each of them, I'll tell you the simple procedure. The simple procedure is, let's suppose You just forget for time being that the question is given in the max term form. So first you write the terms, the mean terms corresponding to this. Okay, so whatever you have done in question number 1 and 2 in the previous questions in the tabulation method, you follow the same thing and write the mean terms corresponding to them. Once you get the mean terms, then take its complement or apply the De Morgan's over that term. Then you'll get the corresponding max term. So you see what we'll do is, see, corresponding to this, if I have to write the mean term, then corresponding to this group, if I have to write the mean term, then how I will write it? Because you see, the dashes are coming in this location, 2 and 4. So our, if I write 8421 code, so 8 and 1, because it is a 4 variable, the expression is having 4 variables. So location 8 and 1 are the terms which are not dash marked. Okay, so you see, if you have to find, let's say, what should be there. So you see, you pick the lowest term. So let's say 8. So 8, if you corresponding to 8, if you write the binary, its binary equivalent, then it will be 1 0 0 0. So you see, 2 and 4 will have dash in it, whereas 1 and 0, A and D location, A will be considered as 1 and D will be considered as 0, because you see, if you write the decimal equivalent, if you write the binary equivalent of 8, it will be 1 dash dash 0. Okay, so that is why. So you see, that is why you have written A dash corresponding to this particular group. Okay, now this particular group, once you have written, now you want the max term corresponding to it. So this is the mean term. Okay, now if you want the max term corresponding to it, what you do, you just take the complement of it. So you see AD dash and its whole complement. So if you apply the De Morgan's, then it will become A complement plus D. So this is what the term which you get. So if the question is being given in the max term form, then you don't have to write this term in the answer. You have to write the answer in this term. So how to get this term? So this is the way, you can write it in the simple form by following the procedure which we have discussed earlier, but this is the other way. So I have told you both the ways. Now similarly you do it for the other essential prime implicants and write the terms. And after writing them, whatever essential prime implicants, these 3 essential prime implicants we are getting, we multiply them together. Okay, and so this is what you get as the expression in the minimum form. So this was all about the tabulation method, and we have seen all the important type of problems which are possible in this case, tabulation method. So to just summarize this particular lecture, okay, so this was a little long lecture and we have completed all the basic fundamentals which will be required in particularly this course. So after this, there will be repetition of whatever you have learned so far. Okay, so now you have to just apply these methods, whatever we have learned in this particular up till this lecture, and particularly in this lecture, so minimization. So this we have to apply in our next few lectures while studying unit 2, unit 3 and the higher units. In fact, until we don't finish this particular course, we have to apply or whatever we have learned in this particular unit. Okay, and particularly the minimization. So be very much have sufficient practice with this minimization techniques, and after you have sufficient practice, then it will be very easy for you to do the things which we have to do in the next unit. So just to summarize, in this particular lecture, we have seen about the basic building blocks, the various gates. Okay, then we have seen the important identities, and the important identities, apart from the important identity A plus A dash is equal to 1, the other, because this is the important identity, because this particular identity is useful not even in the K-map but also in the tabulation method. Okay, and this method, tabulation method, is the method which you can use to automatize the process. Okay, automatically computer can use this method to simplify any given expression. Okay, now then we have seen the questions with Boolean algebra and this universal gate, how to implement any circuit with AND or invert logic, and also with the universal gates. Okay, then there is a method which we have discussed, so we have to just follow that simple method. Then we have also learned that how to simplify the given expression using K-map in SOP and POS form, and also we have learned that what are these forms in fact are: POS form, SOP form, standard form, canonical form. Okay, and we have seen the K-map for 3, 4 and 5 variables, and then we have seen the tabulation method. This tabulation method is that can be used for automatization whereas K-map needs a lot of practice to form groups and then to write the corresponding terms corresponding to them. So this is what we have learned in this particular lecture. So I hope you will revise it sufficiently, and in the next unit we will discuss about the combinational circuits. So thank you for listening. Thank you to all.